Okay, thank you, Diana, and thank you also for inviting me. As it has already been mentioned, how seasonal forecasts are made in most parts of the world. There is one requirement which Roberto mentioned, that is computational cost. It needs a lot of computer time to do those kind of forecasts. So as you know, in Africa, we may not have those kinds of resources. So what are the viable options to do seasonal forecasts in Africa? One method which many of the meteorological services use is a statistical method. What I mean by that is by making a correlation or a relationship between the forecasted or the rainfall with other parameters. So we use, for example, what is called the analog method is one method where forecasters look a year which is pretty much similar to the current year of the forecast. So this is done based on the sea surface temperature forecast that Roberto mentioned from the global models. And there are other methods of statistical methods that has been adopted by the International Research Institute, RI, in Colombia. This one, we call it climate predictability tools. The principle behind it is, it's again the same statistically, having a relationship between the rainfall over the tropical regions or SST over the tropical regions with, say, the East African rainfall. The other one is combining this climate predictability tool with a regression-based. What I mean by regression-based is, again, we use forecasters from the global model and relate that with rainfall over the region. So based on the output, since we don't have the capacity to run these models, we use the output produced by different climate centers and statistically downscale that forecast to be relevant for our region. So this is one of the methods. But statistics and forecast, as mentioned, may have its own advantage and disadvantage, because when you do, for example, when the advantage is it doesn't require a lot of computational resource, it is less complex, and in terms of skill, it is not also bad. It is very much comparable with a dynamical forecast.
And so can you explain how it's easier?
Which one?
Sorry, you talked about how, you know, in addition to the information you've gotten from other, you know, from your statistics, and so how like the climate predictability tools, you know,
yeah,
what are they really about?
Yeah, what the climate predictability tool does is, this is a software, a program already developed to use the forecasted rainfall over the tropical region and relate that with the forecast over Kenya, for example, or Greater Horn of Africa. And this is a relationship that is already set up based on many years of data. So when we get the new forecast from the center, different centers from the global models, this tool can be used to downscale a forecast over a certain region. So this is one tool. And another tool is what we call a regression approach, which is developed by ICPAC. This also uses the same principle. The difference is this one uses a correlation between the rainfall forecast from the global models and the observation. And then that regression equation will be used to predict the seasonal rainfall over the region. So all these methods are statistical methods.
Okay, maybe for the ones who don't understand, can you give us a bit of an explanation about how the observations are done?
The observations can be from the number of stations in the region that are collected, but now we have observation plus satellite data, which is filling the gap in areas where there is no observation. So these have been used for the last many years of data, and this has been used to correlate with the forecasters coming out from the global models. Is that clear? Shall I move?
Yes.
Okay. Now, the question here is, why do seasonal forecasts depend on sea surface temperature on most African countries? As you can see in the map here, there is a strong relationship between what is happening in the Eastern Pacific. When the temperature over Eastern equatorial Pacific becomes warmer or colder, it has a very strong significance on some season over some regions of Africa. For example, the one you see here is on East Africa, where you see the weight on October, November, December. So based on the forecast which Roberto mentioned on the sea surface temperature, we can predict the rainfall over East Africa based on this relationship. So that's why we depend on sea surface temperature over the tropical region. And some seasons, and this has been asked by Diana, you asked, is, for example, is seasonal forecasting much easier over African countries as compared to the others? It depends on the season, and it depends also on the geographic location. For example, this is one case in East Africa where the seasonal rainfall is very much strongly correlated with what we call the Indian Ocean dipole, meaning when the Indian Ocean over this part is warmer, and when it is colder over the eastern part of the Indian Ocean, the October, November, December rainfall over East Africa becomes wet. So we can use this as a predictor whenever we see the positive phase, or when we see the Indian Ocean warming over this area and colder over this area, we can say the October, November, December rainfall over East Africa is much better or wet. And the opposite, it becomes dry when you have this kind of, so it can be used as a predictor.
Yeah, it actually took me a long time to understand the Indian Ocean dipole. So yeah. I do want to maybe ask you here, if, how accurate are these predictions when it comes to like the Indian Ocean dipole?
Yeah, so when we get these forecasts from, was mentioned earlier, a forecast of sea surface temperature over the Indian Oceans like this. For example, this is one case where we call a positive phase. That means when the Indian Ocean is colder over here and warmer over western side, it creates some kind of this circulation, as you can see. And this favors wet or above normal rainfall during October, November, December in the East African region, okay? So this is one of the predictors that we can use. So understanding the ocean, knowing or having a very good forecast of the ocean would help most African countries to have a better skill in seasonal forecast.
Okay.
Yeah. So now let me come to the last one, which is a challenge now. Now, as it has been mentioned, for a seasonal forecast, there are two main things that are necessary. One is observation, as it was mentioned, and another one is the model. So one of the problems that we had in Africa before was the scarcity of data. This is one example I pulled out from Rwanda. Due to conflict, as you can see, data was not existing in many places in Rwanda during this time of the year. And then you would see, because of investment in having data, there was also a decline in the number of stations available in some countries, as you can see in the bottom picture. So this has been a problem. Now, I don't want to only talk about the challenge or the problem, but there is also a prospect coming now, because there is a merged by using whatever available station data, merging it with satellite data, as it has been mentioned. it was able to develop good data sets over African region. One, we call it a CHRIPS dataset, is a name. And also the International Research Institute in Colombia also, they developed a 4-kilometer resolution based on the station and set by combining station and satellite data. And then from, there is what we call the reanalysis data derived from ECMWF also, the ERA 5 data, which has a very good resolution that has come in. So now there is a prospect in terms of data, we are getting a better data. Now also, there is also prospect in terms of the model. Now a lot of models are running with a very high resolution. And the sciences also, understanding of the different components which Roberto mentioned, the land, the ocean, the atmosphere, that is also improving. So these are prospects coming, and I think that would help improve the forecast even in this African region. Thank you.
And all these new possibilities, you know, what is the financial implications of that? You know, is it available to all countries? And what about countries in conflict?
Yeah, I think most of the climate data, I mean, thanks to many of the centers, like the Copernicus under the European Union, and also the North American, what we call NMME, they have produced quite a lot of global model data sets which are available freely to use. So this has been an encouragement for the region, for Africa. And the collaboration now through the different projects like COMFER, Down to Earth, and Focus Africa would help a lot to improve the understanding of the, or improving the seasonal forecast over the region.